Alrighty, welcome back folks. So in the last video we talked about how we could solve this equation, and it turns out that the answer is simply equal to log base 10 of 64 divided by log base 10 of 3. And we decided to choose log base 10 because we have a calculator. Sorry, any calculator can do log base 10. Well, any scientific calculator. Anyway, and so I just wanted to generalize this process. We can see here that this can also be written as log base 3 of 64 is equal to x. And I want to just kind of compare and contrast compare these two expressions, because these are both equal to x. And so if I just bring this down here, what we said is that log base 3 of 64 is equal to log base 10 of 64 divided by log base 10 of 3. And so if I was to generalize this process, notice whatever's inside the argument of the original logarithm seems to be on top here. And whatever the base is, right there, is the argument of the denominator logarithm. So what we can do, sorry, I didn't realize that my mic was so awkward. What we can say then is that if we want to generalize this, let's suppose I have log base b of a is equal to x. Well, we could go through the entire process here and say, well, that would just end up being the same equation as this. B to the x is equal to a. And we can do exactly what we did last time. I could take the logarithm of both sides, and that's where this property comes from. So I'll take, say, log base c. Doesn't actually matter what c is as long as we take the same base logarithm on both sides. So log base c of b to the x is equal to log base c, log base c of a. And we talked about in the last video why this is okay to do. Not only does it look correct, but it should actually be mathematically correct, and we explained last video why it actually makes sense to do this. Now what we can do is, with our logarithm of a power property, is that I can take this exponent inside the argument, that's important, it has to be inside the argument, and bring it to the front. In a sense, you're kind of factoring it out. And so what this says is then that x times log base c of b is equal to log base c of a. And now we can just solve for x. And you get x is equal to log base c of a divided by log base c of b. And so what does that tell us? Well, remember, if we bring it way back to what we started with, this is what we started with, that's what we ended up with. If we were to summarize this, we could essentially say that log base b of a is equal to log base c of a over log base c of b. Now here's the nice thing. C could be literally anything you want. But why would you pick any particular c? Well, you would pick it because based on whatever your calculator can do. So if you have, say, a boring scientific calculator like I do, you can only do log base 10 or log base e, this fancy number e. Sorry, that's the notes from the other day. This property is called the change of base property. Literally, you are changing the base from b to something else. Change of base property. And this is the fourth property. How do you remember this? Well, one way is that you don't actually have to remember it because it's pretty quickly done and dealt with by taking the logarithm of both sides and doing this. So you don't actually need to remember it. But if you're looking for a way to remember it, here's how I remember it. The a, because b is a subscript here on the left side here, since b is a subscript, it's on the bottom. And since a is a superscript, it's not the superscript, but a is on top. Physically, it's on top. It's higher up on your paper. Oops. Sorry about that. Then it stays on top. And so that's how I remember it. Okay. Again, C could be literally anything. It's just you want to generally pick 10 because that's what your calculator can do. Ready? I'll see you in the next video, folks. Thanks for watching.